Balancing equations using the oxidation number method. Reactions must be balanced by mass and by charge. There are two ways. The one I'm going to be looking at in this video is the oxidation number method, but there's also a half reaction method, which we'll be looking at in the next video. Step number 1, we have to assign the oxidation number. So once we assign the oxidation number, we have to identify which one has actually been oxidized and which ones have actually been reduced. Then number 2, determine the number of electrons lost and gained, and then you cancel out those number of electrons lost to equal the number of electrons gained by using the simplest whole number. Why is that important? Because in step number 3, we use this whole number then as the coefficient for both the reactants and products containing these oxidized and reduced species. We then balance these oxidized and reduced species to ensure the electrons transferred are actually balanced naturally on their own. However, this doesn't always occur, okay? In a perfect scenario, this would happen, but sometimes it does not. Then we have to do number 4, we have to balance any remaining by site as an example. So balance using the oxidation number. So for given this reaction here, obviously there's missing some oxidation numbers over here. So obviously this one here all equals to 0 because there's no particular charge for this nitric acid over here. So 3 times -2 gives you a -6. So what does 1 plus what number minus 6 is equal to 0? Obviously a 5. Okay, so you do the same thing here. So then this one would obviously have to be a 3, and this one would obviously have to be a 5. Okay, so now that we've done that, we have to see which one has been reduced. So this one was a 5, and then it became a 2. So it got reduced, it gained electrons. So how many did it gain? Well, what's the difference between the 5 and the 2? Obviously a 3, so it gained 3 electrons. How about this oxidation, right? 3 and then 5, so it increased, right? So it lost electrons because it increased an oxidation number. What's the difference between the 3 and the 5? Obviously a 2, so it lost 2 electrons. Now that we're done that, we have to make sure that we get, what does step number 2 say? We have to use the simplest whole number that both of these numbers can become as a product. So if this is a 3 and this is a 2, obviously 6 would be the case. So this one over here, the HNO3, this is a 3. You have to times it by 2 to make 6. We're going to be putting a 2 over there. This one here is also a 3, so we have to times 2, so that gives us a 6. So we're going to be putting a 2 over here. For this oxidation, so this one over here is a 2, so we have to times 3 to get a 6. So this one here becomes a 3. Same thing here. This is a 2. It has to times 3 to become a 6, so we'll put a 3 over there. If you were to look at every single element here, they actually all balance out naturally, so we can actually skip number 4. All are actually balanced, so we can actually skip number 4. We can ignore it. Please try these 3 questions on your own. Pause the video and I'll be giving you the answer shortly. This is the answer to the first question. This is the answer to the second question. And this is the answer to the third question.